Good afternoon, ladies and gentlemen. Welcome to the group exhibit Hydrogen Fuel Cells Europe here at Hanover Fairground. 2003 is the year that we have right now. I invite you all to come and have a seat. If you're standing around, if you will take a seat in the front row, I promise you a complimentary drink, coffee, tea. We have even, I think, plant milk. So please come and join us here if you're standing around, because this is almost the last presentation here in the public forum for today. After this, though, we have another one that is not on the program, so stay tuned for that as well. So we'll keep the program going on until 5 p.m. At this moment, I would like to greet all our online guests. Assalamu alaikum, ni hao, konnichiwa, bonjour. To all our online guests, we are live streaming. In case you missed an interview and you're interested in the faces behind the companies, there's a QR code that you can scan that directs you to our socials, including our YouTube channel, where all the interviews will be uploaded. So we are going to talk about the alphabet, we are going to talk about PCB-X, and if you want to know more about how the Bramble is delivering the age of electrochemistry, please welcome with me on stage the Business Development Director, Mr. Carsten Pohlmann of Bramble. Welcome. Welcome, Carsten. So, it is a pleasure to have you here. First of all, maybe we could get to know you, Carsten. So give us a little background, who you are.
Yes, of course. Well, thanks first of all to have me on the stage today, to give the opportunity to talk about Bramble. And let me start with myself. My name is Carsten Pohlmann. I've been in the hydrogen sector now since 2008, I think, and have done work in different areas, from hydrogen storage over fuel cell applications. I did some work in Paris. I joined a company in Chemnitz, and now I'm working for a company in the UK. So I could say I've seen quite a lot of Europe. And yeah, today I want to talk about what we are doing so much differently with the Bramble approach.
Yes, and before we come to that, maybe we need to understand who Bramble is.
Yes, I guess so, because we are not that active yet, or not have been that active yet. Well, Bramble is a spin-off from the University College in London. We were founded in 2016. At that time, it was very much focused on three key persons doing the IP work, getting the things into patents. And we then started working on products, on solutions. And currently, we're at a stage where we try to push the boundaries of our PCB-X technology in more or less 4 categories, but I think we will touch that later on. And I joined Bramble last year in October, and ever since we also raised our profile on international trade shows and things like here at the public forum of the Hydrogen and Fuel Cells Europe exhibition.
What I really like is that, well, I was once in university, and you get so passionate about research, and it's just, in university, most likely it's just hypothetical. But when really a spin-off is created and actually a company is founded and the technology is used, it's such a compliment to the students, but also, it proves that we need universities and we need research and invest in our future and the young people.
I couldn't agree more. And in our specific case, we have to thank a lot of people in this place. I don't want to name them all, but we had professors at the UCL that helped us, still helping us, and of course also our investors. We went through several funding rounds. Last year we did our Series B funding in the beginning of last year, so there is some certain trust into what we want to do, and people think that we can change the world with that.
So now let's hear how you can change the world. So what is it actually that you do, and how do you contribute to the hydrogen industry?
Very good question. And like the title suggests, it can be broad, but I would like to narrow it down. We are doing PCB-X. What does PCB stand for? It's the printed circuit board. Printed circuit board, everybody should know, or at least have heard of it. It's those things which you have in your cell phones, in your laptops. It's the things on a motherboard that basically work our electronics.
So it's this little green plate that you have some components
Exactly.
on top. I know this. Yes.
Exactly. But of course, we don't build printed circuit boards. That would be stupid to pronounce that here at the hydrogen and fuel cells area. So what we are doing is we are leveraging this production manufacturing to build electrochemical devices.
Wait a minute. So you use this technology, the PCB boards, and you use it to make electrochemical devices. What kind of electrochemical devices?
Well, we have different application areas. The main focus at the moment is on fuel cells, but we have IP protection into the fields of electrolyzers, redox flow batteries, and hydrogen sensors. Main reason, they are all somehow interconnected. They are, at least in our product portfolio, they follow similar properties or, let's say, requirements which we have with our technology. And like what you said, it's the PCB board or the printed circuit board, but we're not using the printed circuit board itself. We're using this production manufacturing technology. So nowadays you have somewhat like 70 billion industry out there, worldwide established at a high quality. So you have those production sites distributed all over the world. Those production sites, they build our standard PCBs, so what you know. And usually an Apple or anyone else, I don't want to name specific, I did, they're placing orders there. So they're placing orders to build a board for a cell phone, they're placing orders to build a board for a laptop or whatever. And we are doing it in a similar manner. We're placing orders to build a fuel cell. And what is the thing what we're using? We established a process, actually, where we make use of the same tools, the same processes, and the same materials. So we don't touch the PCB world, but make use of the PCB world to build fuel cells. The only thing we have to add is a MEA, so a membrane electrode assembly, and we have to add a certain ink to protect the internal area or the internal surface from corrosion. This ink also is under IP protection and was developed to fit, again, the PCB process. Everything is around the idea to say, okay, what do we see in nowadays world with fuel cells? The main issue, or one of the main issues maybe, is scalability. If you want to scale your fuel cell technology, it has to scale with the market. So if the market is slow, you're scaling slow. You'd never achieve economy of scale easily. In our case, we make a cut between the two. We have the market, and it develops in a certain speed. But our production technology is already scaled. It is already well established, high quality worldwide. I mentioned it already several times. So we're making use of this production technology to harness benefits. And one of the main benefits is, of course, costs. Another one is flexibility in design. Another one is scalability. Scalability in the sense of we can produce either 1 megawatt today or 10 megawatts tomorrow, because we just place more orders at different sites.
Well, and then distribution, because I assume this is a well-known technology established already and all around the world, so it's ubiquitous, accessible, so you can have it on site. You don't have to wait for shipping for such a long time.
In a way, that's true. There is obviously some certain requirements to it, but essentially what we are saying is we have a globally network which we can use for local value chains. So we could imagine working with a client, let's say in India, building a local supply chain there to support the market there. We could have the same scenario in Japan, in Europe, or in the Americas. That doesn't really matter because you have those suppliers out there. The main difference still is we're producing one single cell. So from those PCB production sites, we receive one single cell, and that still has to be stacked and put into a system.
Yeah.
So that is still something which is needed to be done, and for that we are looking for partners, right? We're looking for integrators, for potential clients that want to do that with us in their specific region, for their specific applications, for their specific markets.
So just to give an example, so you just mentioned that this is kind of genius to use the PCB technology on fuel cell stacks. I'm just wondering, just also for the audience, to understand the business model better. So are you the one producing the fuel cells? Or are you also able to let others use your technologies with their fuel cell design?
It's a very good question. Well, the main goal at the end is licensing. So we want to license this technology to specific partners, specific clients. Obviously, at our current stage, we're doing demonstrations, right? So we need to understand the technology further. We are looking into durability aspects. We're looking into scaling aspects, so going to higher powers and things like that. So obviously, we have our own network in terms of building a system, doing integration, and also knowing the people which are necessary to build such a system. So it means we also can support an external client.
So who is your ideal client?
That's also it's a bit a complicated question for that matter, because since we're so versatile, it could be someone who looks for an easy entrance into the technology, right? Meaning, okay, I'm just assuming, I'm coming from internal combustion engines, I want to do something different, I'm scared of the high complexity of fuel cells, it's cost intensive because you have a lot of capex. We could offer an easy entrance because you actually don't have to invest in factories in the beginning. It could be, on the other hand, also somebody who's already well versed in hydrogen and fuel cells, for instance, an integrator who wants to explore his value chain in a vertical direction or also in a horizontal direction. So there are several fields which we could imagine. At the moment, we are not bound to anyone yet, so we are quite open, as we are also still a quite young company.
Is there a minimum order amount?
Well, that is something depending on price, obviously, right? So if you're talking about a prototype, you have a certain price. I won't disclose it here, but what we're aiming at, and there will be also a white paper coming out this year, is a certain price structure. So we're looking at a pathway of 100 pounds per kilowatt on a stack level. That's our pathway. We will have a white paper on that, which also will outline all the nitty-gritty details around how to achieve that, what are the details in terms of what are we looking at scale or at, let's say, production capacity, those kind of things. That's one part of it. The other part of it, when we're looking into the technology, is on a technology roadmap, we want to increase power density because it's clear we need to go to higher power densities. So currently, we're at a level of round about 2 kilowatts per liter and kilogram, and we're aiming towards the end of the year at something like 3 kilowatts per kilogram and 4 kilowatts per liter. And that we can achieve relatively fastly also because the printed circuit board industry allows us to scale, to produce very rapidly. It means, for instance, if you're doing, let's say, a fuel cell out of graphite or out of metal bipolar plates, you have to have tools, right? So you have a new design, you build a new tool. Before you have something in your hand as a hardware, it takes you several months. If we have a CAD design, we can be as fast as 10 days to have an actual hardware in our hand. So that helps us to design and iterate our technology quite fastly.
I love how passionate you are, Carsten.
Thank you.
And I think some of the audience agree with me on that. Which questions do you have at this time? Please raise your hand so that I can come down to you.
Hi, my main question is you often said that you replace fuel cells by this PCB technology, but when I think about a fuel cell, it's a three-dimensional device with bipolar plates and a humidifier and different features, and a circuit board is a two-dimensional thing. So what are you actually replacing? Is it like the bipolar plate itself, where you put the MEA on, or which part of the fuel cell are you replacing?
Well, thanks for that question, because then I need to be more clear on that. First of all, we have fuel cell system, right? So what you mentioned, all the balance of plant components, there we're using exactly the same what's in the industry. We don't touch that. Our main IP, our competence is on the stack. And within the stack, you have those single fuel cells, right? You stack fuel cell by fuel cell by fuel cell to receive a stack. So we're not really replacing the fuel cell, we're building a new fuel cell from this printed circuit board materials. And in printed circuit board, you have multi-layer approach. So we're basically building layer by layer, each layer with a different function. So the first layer having like a copper surface to have an electric contact to the next cell. Then you add another layer with some cavities for hydrogen distribution. You integrate your membrane in there. You add another layer with the cavities for air, and so on and so forth. So you build it layer by layer. Everything is laminated together, and then you have actually one fuel cell, which obviously is somewhat 2D, but has an internal 3D structure.
Yeah, thank you for that question. That was very good also to make it more visible in my brain. Last question, Carsten, unfortunately already. So I would like to know from you, you mentioned Bramble as a startup, and I'm curious what it is like to work as a startup in the hydrogen industry, because I feel like if I compare hydrogen compared to other industries, hydrogen itself also feels like a startup, right? So I just wonder how this is matching.
Well, like I said, I've been in the industry since 2008, and I started at the Fraunhofer Institute, and after that I was always in a startup, so I know the startup feeling. But like you said, the whole industry is still quite startup-y, which sometimes means, for instance, with our competitors, you don't have yet such a strong competitiveness. You still can exchange on balance of plant components, for instance, in projects. There's, for instance, the European project STASH, where like 11 fuel cell manufacturers work together to define a standard for the heavy-duty industry. So we still have this collaboration. And you can see it here at the trade show, or especially at this exhibition area, when in the evening we have our networking events, everything is very friendly still. And that's what makes the feeling.
Still, he said still, but I think it will always be friendly.
You never know.
No, I get the point that you say that we are learning from each other, we are collaborating, we are learning, we are all in this together. The market is for everyone, but we can only drive the market if we are friendly with each other, share the knowledge, learn from each other, and also be compassionate, because not everything is working out well, right? There are ups and downs that we have been facing. You mentioned you've been also in the industry for more than 10 years already, so you probably also were an observant of the ups and downs in the market.
Definitely.
Very last question, but what's your personal wish? What do we need from the society, from the government, from the competitors? What do we really need to ramp up the hydrogen industry?
Well, that always, in my opinion, because I'm also very much involved in Hydrogen Europe, comes down to regulation. So we have a lot of issues around regulations. So either they're not in place, they're not well meant, or they take too long to put in place. So most of the cases, I would say to the political stakeholders, be faster. Listen to your technical stakeholders and make it happen. Be technology neutral, yes, that's important, but build guidelines that you can actually build a business and that you can build it reliably, right? Because even if the guideline is a little bit to the disadvantage of one or the other, at least it's there and it's not vague.
I highly agree. So we are basically saying, please, European Union and all other politicians, everyone who is providing a political framework, be more agile, be and think like a startup. Thank you very much. That was Carsten from Bramble. If you want to know more about this genius technology, and also if you want to know more about Bramble as a company, Carsten will be here to answer all your questions at booth number E46. It's E46. Thank you so much.
Thank you.